Hello friends, I welcome all of you in this wonderful world of AAC Blocks. In our session today, we will look at what are AAC blocks, how are they manufactured and why they are so important today. What are their benefits and how we should use them on site. So let's begin with our session. Friends, since 5000 years ago, as you can see in the picture, in the excavations in one of the old Indian cities, Mohenjo-daro, clay bricks have been found and they are 5000 years old and exactly the same clay brick which we still see around, the same size, the same shape. So over last 5000 years, so many things changed, but the thing that remained constant was red clay brick. So of course it was a great product. Why? Because it kept the heat from coming inside, number one. Number two, it was very easy to make, very fast to produce, and the production cost was low. However, over the period of time, as our population increased, as the cities grew, the demand on the clay for making this brick started to increase. And as you have seen with everything around us, it started leading to environmental degradation. The topsoil is so critical for us, and if we remove it and use it in clay bricks, then it results into deforestation, surface water runoff, and loss of the groundwater. So with all this background, various governments came up with notification urging people not to use red clay brick. But what was the alternative? The story of the alternative begins 100 years ago in Europe. It was year 1920 when, after the First World War, there was destruction in Europe, and the scientists, the architects, the engineers, they were looking for a product which will stop the cold from coming inside. That was the requirement in Europe. In many of our countries like us, India, our requirement is to stop the heat from coming inside. The purpose is same, thermal insulation. You want a product which will have a very low thermal conductivity, and therefore the story of AAC began when a Swedish scientist, Ericsson, he invented this product by combining various processes like autoclave, aeration, and then making a block out of it. So what do we mean by autoclave? The big vessel which you see on your screen is the long autoclave in which the blocks are kept inside, the doors are closed, and you give a pressure with steam, 200 degrees centigrade temperature and 12 bar pressure. So you can call it a pressure cooker. We all have a pressure cooker right in our kitchens. So this is a kind of pressure cooker where the pressure is far bigger than what is in our kitchen. The kitchen pressure cooker has a pressure of around 0.5 bars, but in this case it is 12 bars. So 24 times higher pressure in this autoclave, and literally you are cooking the blocks inside. What happens because of autoclaving? Normally on our construction sites we have seen that we do curing for 7 days, 10 days on concrete for the strength development. The final strength of concrete comes after 28 days. But with autoclaving you get that 28 days strength in just 12 hours by giving it the heat. So that was the one part of AAC technology, autoclaving. The second part was aeration. So aeration is you induce air in the product to make it lightweight. When the product becomes lightweight, the AAC blocks, they are so light that they float on water. They have a density half of water, and that gives us numerous other benefits which we will go ahead and see. So A, the third is C, concrete. But this is a concrete where there are no aggregate stones. no heavy materials, finely ground sand or fly ash is used in making AAC blocks, and these are the filler materials, these are the aggregates which are used in AAC blocks. So these AAC blocks began in Europe after 1920 and very rapidly they became popular, and then this technology started going in various countries within Europe. But after the year 2000, this technology has gone all over the world, and we see Asia, China, Japan, India, Indonesia, Thailand, all these countries, AAC blocks are being used in a very big way. Why? Because we want to stop the heat from coming inside. Europe has been using it since 100 years, and now this product has also gone to America as well as Australia. Even in Africa, the things have started happening when it comes to AAC. So friends, I call AAC a bread of concrete because there are three similarities. The first one is, if you look at the bread, it has got that aerated structure in it, right? Similar aerated structure is there is AAC. So in AAC there is not like a hollow block that there is a hollow portion inside. There are millions of tiny air bubbles which make it lightweight. The second similarity between a bread and AAC is that the aeration inside the bread is a cellular structure. So there are cells similar to AAC, and these cells are like a honeycomb structure, and because of the independent cells, the water cannot pass easily. That is an important benefit of AAC. The third similarity is both are lightweight structures, our bread as well as our AAC. There is only one difference in them. You know what? You cannot eat AAC with jam and butter. So with aeration, with cellular structure, as I spoke to you when I was talking about bread, you can see here that there are millions of cells, and this is a very closely taken photograph, not a microscopic image. So these are the cells which you can see with your naked eyes, and the typical size of a cell is around 1 millimeter, and you can see that the wall between each two cells, there is a separation, there is a wall of our AAC material, and that makes capillary action difficult to happen, and therefore the water seepage issues are far less with AAC compared to red bricks. There are numerous standards all over the world when it comes to AAC. I have taken a snapshot of a very nice Indian standard which tells us about various density classes you can have. Just don't get confused, just focus on that yellow band 551 to 650. So that is one of the density class a manufacturer can manufacture and sell to the market. Then there are strengths given. You can either make 4 MPa block or you can make a 3 MPa block. But the final column is so important. It is the thermal conductivity. We discussed that, right? It should be as low as possible so that the heat or the cold will not come in your house. So the AAC block thermal conductivity value is 0.24 watts per meter degree Kelvin. This means for 1 degree increase in outside temperature, how much heat will increase inside your room measured in terms of watts per meter thickness of your wall. So when we talk about density and AAC blocks and various benefits that come, let's compare density of few popular materials. So we start with bricks because we have been using them, and bricks have a density of around 1500 kg per meter cube. What do we mean by density? As we go ahead, you will see that lower the density, material becomes lighter, right? So remember, bricks value is 1500. Then we go to hollow blocks. So today in the world, in many places, bricks have been replaced by a slightly better product, which is hollow blocks. But look at the density figure. You have not drastically reduced the density. it was 1500 for bricks, you have made it little bit lightweight by bringing it down to 1300 kg per meter cube. Let's go ahead. We come to water. So you can see that water is lighter than bricks and hollow blocks. You can see the densities on the side, so that if you forget, water is 1000, bricks is 1500 and hollow blocks is 1300. So we have reached up to water, right? You know, our 1 liter mineral water, the weight of that is 1 kg, 1 kg per liter, or 1000 kgs per meter cube. Lighter than water, of course, wood, we all know that the density is 700. Now we know that the wood floats on water, right? So it is lighter than water. So the density is lower than water. Then we come to apple. I am not talking about your mobile, I am talking about the apples which we eat, and the density is even lighter than wood. It is 650 kg per meter cube. As we go ahead, we come to AAC blocks now. So the density of AAC blocks in India, you can make blocks as low as 450 kg per meter cube. And you can compare now on the screen, you can read it starting from the bricks 1500, hollow blocks 1300, water 1000, wood 700, apple the fruit 650, and AAC blocks here at 450. So AAC blocks, they float on water because they are almost half the weight of water. And finally, I compare all them with aeroplane, right, which has a density of 100 kg per meter cube, very lightweight. And it is my dream that with all the technocrats in the world, people working on this product, maybe I hope in my lifetime I will be able to see AAC blocks as light as aeroplane, 100 kg per meter cube. Imagine the benefits it will bring. As it is, we will see in the next slide how AAC blocks give us tremendous benefits. So when we say low density, what do we mean? That the size of the block, you can make it really big, because your mason will be able to lift it, place it, and almost 8 bricks are equivalent to 1 block. So instead of putting 8 bricks, you can just put 1 block. So all the joints are also saved, or the mortar which is going to go inside, you save lot of cement and sand. So that is a major benefit with AAC blocks, that you can make a much bigger block, you can save the joints, and you can increase the speed of construction. So all 3 points are connected with it being a low density material. Otherwise we would not get these benefits. Because it is light in weight, the transport cost is less. For a standard truck, let's say of a 20-ton capacity, you can transport almost 35 to 50% more blocks in the truck compared to other products. So what happens because of that? You save fuel. It is not only the efficiently using a truck, but you also save carbon footprint. And you are making your building, your high-rise building, and you are reducing so much weight from the building. This is a dead weight. You don't need it. This is just masonry walls. Why you need it to be heavyweight? So you can make your columns, your beams, your foundations with smaller sections. You can use less concrete. You can use less steel. Why? Because the load of the building has reduced substantially. And now we compare all these products that we have already spoken about quickly in 2-3 values. Don't worry, I will not bore you with all these values. The first one is dimensional accuracy. Many times clay bricks are handmade, they are irregular in shape. So when you use AAC blocks, it's a machine made, it's a factory made product, and the accuracy is 2 to 3 mm. So all your work can be in nice line and level, in exact plumb. Fire resistance is so important. Many times we ignore this, but this is an important property of AAC blocks, and on many prestigious projects AAC is specified just because of this property, that it stops your fire. The fire resistance of AAC blocks is 4 hours. compared to all other building materials. Very important point to note. And of course, thermal conductivity we have seen. Now, red brick, I told you in the very first slide, it's a good product. Since 5000 years, human beings have been using it. Why? Because it stops the heat from coming inside. But look at the thermal conductivity value, it is 0.85 compared to 0.2 of your AAC blocks. So it is far higher than AAC blocks, and AAC blocks are far better. They are very low, 1/4 thermal conductivity of a red clay brick. If you look at for example, solid concrete blocks, they are 1.3, so many times, almost 6 times more than our AAC blocks. So this is an important property for which these blocks were invented, and that's how they became very popular. So they were invented for stopping the heat or cold coming inside. To make that happen, we made them lightweight. Because we made them lightweight, we got so many other benefits. Faster speed of construction, less mortar joints, less concrete and steel required, lower cost of construction, lower cost of transportation, and all the green benefits that come with it. We make the surface of AAC blocks slightly corrugated, grooved surface, so that the plaster can hold properly on your wall. This is a concern for many of our builders and developers. Wall thickness, if you are going to make a load bearing construction, so no columns, no beams, just walls and a roof on top. So in that case, it is 150 mm is your internal wall thickness and 200 mm is external. This is minimum. You cannot make very thin walls if it is going to be a load bearing construction. But most of us, we do a non-load bearing construction, 90%, I would say even 95%. Why? Because we have beams, columns, and we make multi-story buildings, we make high-rise buildings, and in that case, because you have beams and columns, you can reduce the wall thickness as given in the code IS 6041. The internal walls would be 100 mm and the external walls would be 150. So friends, let's look at the key benefits which I have already discussed with you. Lightweight, lower concrete and steel. Aeration, more fire resistance. Superior thermal efficiency, reduces the cooling load of a building. Imagine I am sitting in this room and I need a 2-ton AC air conditioner to cool down. But if the same room is done with AAC, instead of clay bricks, you can do the job in 1.5 tons of air conditioning. So there is lifelong saving in your air conditioning cost. Larger blocks, faster masonry work, less joints, lower labor cost, low environmental impact because we need so much less material. You are making a lightweight block which has got 1/3 weight, so you are using 1/3 less material inside. So imagine the amount of carbon footprint we are saving. Apart from that, we also use some recycled materials like gypsum. In some countries like India, we also use recycled material like fly ash. So all this adds to the benefits of AAC blocks and it becomes a green product. Also superior sound insulation and better earthquake resistance. Friends, many earthquake prone countries like Japan, they focus on lightweight construction because if your structure is lightweight, then there is lesser chance of damage during a severe earthquake, and therefore AAC blocks offer us an important property of earthquake resistance. Friends, you can also refer to my book Mastering AAC Blocks, which is available on Amazon. In this book, I discuss theory of AAC, how AAC is done, production, the actual production facility, as well as testing, how you can test AAC blocks. Then there are masonry work procedure. So I have discussed step by step in the book how you can use blocks practically on site with pictures. I discuss it in my book. So normally we all use polymer based mortar for the construction of the wall with AAC blocks, not the conventional sand cement on-site mix. So this offers us a very small thickness, just in 3 millimeters you can have a wonderful construction, and you don't need any water curing because it consists of polymers. So friends, since last 500 million years there is life on earth. Initially the life began in sea, then the life slowly came on land, then we had animals, then we had birds, and only since about last 1 million years the humans have come on this earth. And practically in last 10,000 years we have completely screwed our planet. Why? Because of our population explosion and the amount of stress we are putting on the resources of this planet. For example, we dug up our soil in 30 minutes, make clay bricks out of it, and the nature takes 500 years to convert 1 inch of rock into topsoil again. That is the kind of attack we have been doing on this planet, and therefore I hope we all will look at the green technology as we move ahead. We think about environment, we talk about environment, but are our actions congruent with our thought and our speech? Think about this aspect, and whenever you do your construction, let's focus on the green materials. Thank you so much.